So in the earlier part we spoke about what is a chiral center. So if 4 different groups are present on the carbon atom, that is the chiral center. Now how is this going to affect the optical activity? So before going into that, few, you can say glossary, few definitions, because we are going to use these words. What is optical activity? As we have discussed, if the plane polarized light, it is deflected by some angle by a molecule, then we say there is some optical activity for the molecule. And the compound or the molecule, we call it as optically active compound. So what is an optically active compound? That compound which rotates the plane polarized light. What is optically inactive compound? For an optically inactive compound, previously also the direction of light is like this. At the end, after passing through the compound, also the direction of the light is the same. There is no angle of rotation. So then the compound is optically inactive compound. Next comes achiral molecule. So achiral molecule means the molecule is symmetric. That is, you can cut into equal halves. There is some symmetry element in the molecule. So if the molecule is achiral, then you can say it is optically inactive. What is inactive? Even if you pass plane polarized light through it, it looks the same. Why? Because there is some symmetry element, it will distribute the light in the equal. So that is an achiral molecule or a symmetric molecule. If it is hand-like, you have to call it chiral. So if there is a chiral center, generally it will be chiral. Other cases are also there. If there is a chiral center, there is a chance that it will be chiral most of the times. If it is chiral, then there is no symmetry. Hand-like means no symmetry. If there is no symmetry, only in such a case it will deflect the light. That is, it will bend the light. If it is bending the light, then it will become optically active. Is that point clear? If it is chiral, that means the whole molecule is chiral. That means there is no symmetry in the molecule. If there is no symmetry, I am calling it asymmetric molecule. Since there is no symmetry, the compound is optically active. That point is clear. Now moving ahead, generally now whenever you attempt questions, you have to think through this pattern. What is the condition for optical activity? The condition for optical activity is the overall molecule, that is this, the overall molecule must be chiral. Remember, crucial point, I am not saying there should be chiral center. That is not the necessary condition. People generally have this as the misconception. Chiral center is there. It might be active, it might be inactive. But the overall molecule is chiral, then the compound is optically active. If overall molecule is chiral, it means overall molecule there is no symmetry in it, or overall molecule is asymmetrical. If the molecule is asymmetrical, that is a molecule is chiral, then we say there is optical activity. So that is the necessary condition for optical activity. Now we are seeing this condition through the lens of chiral centers, because we spoke what is chiral center already. So based on chiral centers, we will speak about the condition for optical activity. So I can divide it into two conditions. Condition 1, when the number of chiral center is just one chiral center. That is, take a carbon atom with 4 different groups like chlorine, bromine, fluorine, iodine. If there is just one chiral center, automatically the molecule becomes asymmetrical. You cannot cut it to 2 equal halves. Then definitely you are going to have a mirror image of the compound, which I have shown by rotating in the earlier part. So this is the compound, it has a mirror image. The mirror image and this compound are completely different. They are non-superimposable, that is, you cannot place it on that mirror image. That means this molecule is different from the mirror image. So 2 such molecules are possible. So these 2 molecules will be called enantiomers. What are enantiomers? They are non-superimposable, but they are mirror images of each other. And there is only one chiral center, then definitely they are going to be enantiomers. So this is one way. If one chiral center is there, then the molecule is going to be optically active. If more than one chiral center is there, or 0 chiral centers are there, still the compound can be optically active. But what is the necessary condition? It is nothing but the initial point that we have discussed. That is, overall, if no chiral centers or more than one chiral center is there, irrespective of that, whole molecule should be chiral. That is, whole molecule should not have any symmetry. That is, whole molecule should be asymmetrical. How do you decide whether the compound is whole molecule asymmetrical? there should not be any symmetry element. What is symmetry element? We'll be covering that next, but a simple idea, symmetry element means there should not be a plane of symmetry. For example, plane of symmetry is symmetry element. There should not be axis of symmetry, that is a symmetry element. Plane of symmetry means, suppose I take this duster, I am able to cut into two equal halves. So there is a symmetry element. But if I take hand, I cannot cut into two equal halves. That means in this there is no symmetry element, or plane of symmetry won't work. If there is no symmetry element, molecule is asymmetrical. So if molecule is asymmetrical, even though no chiral center is present or more than one chiral center is present, it will be optically active. So repeating this as a whole, the most important condition is asymmetry of the molecule, that is chirality of the molecule. Why we are seeing it in two ways? If one chiral center is there, definitely molecule is also chiral. But if more than one chiral center is there, suppose two chiral centers are there, then there is a chance that this chiral center and this chiral center together, I may be able to cut through both the chiral centers and both of them are equal. So in such a scenario, if even number of chiral centers are there, there might not be symmetry in the molecule. So there might be symmetry in the molecule in spite of having chiral centers. So to eliminate that possibility, we are saying that there will be overall symmetry in the molecule. There will be overall asymmetry in the molecule, which is a suitable condition for optical activity.